So welcome officially to this closing event of session number 8 of School of AI 2021 Q2. Again, remotely this time. We're making it work. It's a different experience. It involves different habits and different challenges than making the same thing work in person, but we're doing a pretty good job, I think, of this thing, considering the number of time zones that we cover, the number of nationalities that we're putting together in one virtual place. I think this is working pretty well. So before we speak about each of the challenges, I wanted to speak a bit about what's going on. So this is kind of like a regular meeting now for a couple of you. We're meeting essentially every 6 months with new pitches from new challenges that we have worked on at PySchool, and I'll seize the opportunity to give a couple of news about PyCampus as well to keep you updated. So for those of you who don't know us that well, maybe some of you need to mute the microphone, by the way. That would be cool if you can do that. So PyCampus is an investment fund, and we invest essentially in applied AI startups. We've done 49 investments by now, and we invest between 50 and 500,000 euros in the startups that we work with. And in exchange, we take a small part of the shares that they have. We're also a physical place. So PyCampus is here in Rome, in the Eur district. And actually, a number of the startups we have investments in are physically our neighbors here. We have all these investments today. The number keeps increasing. The ones on the far right are the latest ones. So it's quite a few people by now that is within reach of the PyCampus network, I would say. There are two companies that stand out. One is Grin, which is a scooter rental company, a very big one by now, and also Boom, which makes a supersonic jet, which I'm going to speak about in a second because we have news from Boom. So here is Boom. So Boom is essentially making the new Concorde, but also in a commercially successful shape. So they're making a supersonic plane. The name of the model or the name of the plane is, as you can see here on the slide, is called Overture. And it's planned to take passengers, 55 passengers, say from London to New York in 3 hours and 15. The plan is for it to be priced like business class. So for the route that I just said, it should cost about between $2,000 and $3,000. And this is also the route, accidentally I learned that was the only commercially viable route for the Concorde. But in modern terms, the Concorde flight would cost $20,000, not an order of magnitude less like what we have from Boom. What you have in the inset instead is the baby model of the Overture. It's the model that is used for trials and tests currently. So it's done a couple of trial flights already. And the big news that we're happy to announce is that a couple of weeks ago, United Airlines committed to orders for an amount of $3 billion. That's 15 of these planes with options for more. And so this is an extremely big news for Boom. It had some firm orders before. It's somewhat below 100 planes by now. And it's big news because it's another sign of traction, clearly. And it's a sign that things are picking up commercially. So the story of Boom is that they started off, PyCampus was one of the very early investors with 50 and then another $300,000. It was a very obviously profitable and therefore we were a profitable investment. Therefore we were very lucky to be among the very early investors, the ones who would support this company very early on. And the way that they would demonstrate traction very early on was because they got pre-orders, letters of intent, non-binding orders, if you will. And now progressively, several of these are turning into firm orders. So this is really interesting news. On another, in another field, Translated got invited at the Gran Premio Internazionale del Doppiaggio. That's the international prize for dubbing, which is held in Rome every year. This is to celebrate or to speak about one piece of technology that we're developing at Translated, which is expressive speech synthesis. So many of you know that apart from my job at PySchool, I also work at Translated. And so within the AI team at Translated, we developed this technology, and I just wanted to make you listen to a couple of samples from our latest voices here. So we have several of these. Let me try and play this.
Viva la scuola, abbasso la scuola. Scuola buona, scuola cattiva. Lo scaffale di libri sulla scuola è affollatissimo.
So this is an Italian voice, as you can hear. It's all synthetic, and we believe it's really, really high quality and extremely expressive. This is another style of voice.
Viva la scuola, abbasso la scuola. Scuola buona, scuola cattiva.
And others still.
Viva la scuola, abbasso la scuola. Scuola buona, scuola cattiva.
Okay, we have female voices too.
Viva la scuola, abbasso la scuola. Scuola buona,
Viva la scuola,
scuola...
abbasso la scuola.
Got two running at once. And we're expanding the number of languages currently. So we're trying to achieve coverage of 5 languages in both male and female versions.
Long live the school, down with...
Now I have to run Spanish.
Larga vida a la escuela, abajo la escuela, buena escuela, mala escuela.
Here we go. So this is where we are at. We think that the quality that we're reaching with the technology we've developed is really high, and we're looking forward to turn, well, MadeDub into a product. You can find news of MadeDub and the technology behind on madedub.com. Other news from PyCampus, Allelica, and here I'm happy to report that one of the persons, namely this guy here, Alessandro Bolli, is an alumnus from PySchool. Allelica is a company that works on polygenic risk scoring, which is a technique that helps making sense of genetic readings of DNA analysis, essentially, and to predict the susceptibility to diseases or other issues due to that can be diagnosed from genetic information in a sort of scientifically very strong and very strongly proven way. And so the news here is that they recently got a publication in a specialized scientific journal called Circulation on polygenic risk scoring for issues due to cholesterol. And so we're really happy that Alessandro is one of the authors here, the first author of the publication. At PySchool itself, we've been working on a project with the European Commission, namely with the Joint Research Center of the EU, which is a place where the EU has many research groups. The one that we're partnering with here is working on sustainability and pollution prevention issues. And in particular, what they're trying to do is to produce directories or maps of best practices in the industry domain, and especially as far as sustainability and pollution prevention are concerned. And what we're doing for them is we're helping them to connect the specialist documentation that they write. Essentially, these ref documents are books. We're trying to connect them with patents in order to make sense of them, be able to look up the technical documentation that corresponds to patents and vice versa as well. So we're developing some similarity search here essentially using techniques that come from BERT and transformer technology to build our recommendation engine to put together these bits and pieces of technical documentation with patents here. Okay, School of AI, the program that we're speaking about today, you know, it takes place several times a year. Currently, we're doing 2 times a year. And what we're doing is we're inviting a certain number of AI specialists to, well, AI engineers at first, and we turn them into specialists. That's the way we like to present it. We invite them to apply at School of AI. We've selected all of the people that you'll see in a couple of minutes present their own project. And the project we source from the industry, and so very many of you in this call today have actually been in this position, so you know what we're speaking of. And so here today we're presenting another 6 challenges, and by now I'm happy to report that, you know, this thing is growing. We've already had 8 sessions, and so that means we have solved 72 challenges. And the community of alumni has now grown to 150 people, okay? And our next session will take place, session number 9, will take place in Q4 of this year. And so we're really looking forward for new and interesting and difficult challenges to crack. And obviously we're also looking forward to applications from you guys or from friends, people that you might want to send our way. Not even going through the portfolio because it's too long to speak about now these days. And so what I'd like to do is, without further ado, is I'd like to call up everyone from the teams and get ready to present your own challenge. So I'll stop screen sharing and I'll hand over to teams now. We'll have presentations from the 6 teams.
Hello, everyone.
Hi, Mohammed. We can hear you. You're showing your slides, and we're ready to go as far as we're concerned.
Hey, he froze.
Lucky.
Yeah, all that froze. Okay, so you know what? We'll just move on to the next presentation, and then we'll pick up.
Yeah, but I cannot share because it is sharing.
Okay, that's
okay.
a situation. Anything that our master of ceremonies.
Okay, no problem. Maybe I can. Okay, wait.
Joao?
I think we can share because I tried sharing and it worked.
Shall I go, Seba?
Yeah, you just go.
Okay. Good evening, everyone. And this is our project, Intelligent Email Processing. As you probably know, the amount of information in the world to be processed is enormous, and this amount is increasing day by day, year by year. And oftentimes, these processes often involves low-level and very repetitive tasks. RPA stands for Robotic Process Automation, and encloses is an acronym that encloses every software or tools to drastically reduce or completely remove the need of human intervention. It is estimated that last year's only the biggest and smartest company would use such solutions, but as of 2021, at least 90% from medium to big companies will adopt such softwares. The downside of such softwares is that they generally require technical intervention, and thus small companies, they are less feasible for small companies because they have to invest part of their budget into setting these softwares up. And Claudio is the solution developed by the Italian startup Automio, which is the first completely graphical RPA tool. So it can be used by everyone from big caps to end users. And thanks to its ease of usage, it's growing very rapidly, very fast, and expected to double its turnover by the end of 2021. Indeed, one of the most boring and repetitive tasks, and especially time-consuming one, is email screening manually. And thus, Automio asked us for a prototype of a new feature, which is basically a new node for Claudio for detection of intents of emails, in order for them to be forwarded to any customizable workflow designed by the customers. This model had to reach state-of-the-art performances using a free model available to everyone, so no shareware and expensive software, highly customizable by every customer, and especially he needed to have as little data as possible in order for it to be deployable. In this 8 weeks project, we were able to deploy and release such model, and it's based on BERT. BERT is a transformer, and in particular, we choose a pre-trained model based on a big Italian corpus of document that was fine-tuned on the data we were provided with. This model reaches state-of-the-art performances in many language-related benchmarks, and the main advantage is that it's very easy to set up for new customers because every new customer can just add their label, and only from 5 to 10 emails per class per new customer are needed in order for it to reach a successful degree of accuracy. In addition, in the future, this model can be easily improved for the multi-labels and multilingual problem. You just need to change the pre-trained model. Not only we proved our results on the data of Automio's data, but we also applied it on different data sets with different sources. And of course, the performances change by the quality of the data set and also the number of classes. But we are definitely sure that this will be a successful feature because as the number of new customers will increase, also the number of the performance of the model will, as you can see from the red line. Finally, current revenues in the RPA market are around 2 billion. But after the democratization of this software that will allow also small companies and end users to access such technology, we are sure that this value will exponentially increase. I am Francesco Puda, a data scientist consultant at the moment for Mediatica, and this project was carried out together with Zeno Belligoli, data scientist at ING and PhD in aerospace engineering. Thank you.
Thank you. Thanks, Francesco. So you can unshare then. We'll have.
Are we doing email understanding, or are we going back to?
Wanted to give it a go? Let's go then. You're ready. So Mohammed, take Mohammed next. No problem.
So hello everyone. This project is about email understanding. It's been given to us by Translated. I think it's been introduced by Sebastian earlier, but basically here it's used. It concerns us because Translated creates professional translation services, and our task here is about mainly email classification and information extraction from those emails. So Translated receives about 4,000 emails like the one you see on the left here. Although those emails can be written in any language and can really be about anything. So here on the left side, you can see an email that's actually a quote request. So that's what Translated is interested about. Usually it's not only those emails, they can really be like any type of emails, and that's why you need to filter them. So the Translated pipeline goes like that. The client brings a quote request. Then the account manager at Translated presents an offer to the client, who can either accept it or reject it. So why do we need automation here? Because humans are perfectly capable of doing this job. Usually you would think that automation is made to replace some human labor. So that's actually a reason why it's important in this case. But the main point here is the conversion rate. So the speed at which the emails are processed is extremely important for the conversion rate. And it turns out that machines are much faster than humans at treating the emails. So this is why we really need this. And a 30 minutes reduction in the response time gives a 15% increase in conversion rates, which is huge for the company and for the revenues. Why is automation not trivial in that case? So the labels here are made automatically. So they're quite noisy and need like a little bit more cleanup. And the data annotation is not adapted to classic information extraction, the one we used to for classic machine learning models. So now let's look at the technical problem. You can see on the left side is the email that we saw earlier. We can see that here Susan Smith is asking, hi, I want documents translated from German and Italian to English. And it's about 3,000 words each, and they're legal documents requiring a review. So our model should read this email and first of all, figure out that it is a quote request, understand that the type of the request is a translation, and that the translations that are asked are from German to English and from Italian to English. And then finally, it needs to extract the name of the person that you have to contact. So here it's Susan Smith.
Okay, so in the last 8 weeks, we have developed an automatic solution that will totally help translate it. This project is mainly divided into tasks. As you can see, this is like the first task in which we receive the email, then we pre-process the email, and this pre-processing email is the input to the request model classification. After this, we have like the email request, and because we don't have annotation data for doing slot filling directly, we decided to change the problem to a multi-level classification and to a name entity recognition problem. So with these two approaches, we can detect the job type, the source and target languages, and also extract contact information from those emails. For doing this project, we have used multilingual Roberta transformer from Facebook and also a deep learning model from Google, which is multilingual BERT. Here are some results for the classification task. In this slide, you can appreciate that, for example, our multilingual Roberta model achieved an AUC of 93. And with this model, we can discard automatically 20% of the emails and also rank all the emails to be reviewed by an account manager. In the case of the slot filling task, we have achieved in the field of language an accuracy of 72%, in the field of service required an accuracy of 82, and in contact information, a precision of 83 and a recall of 84. Finally, our work could be implemented in a bot. As you can see in a previously used bot in production, increased the productivity in June by making 60% of all the offers automatically. Some future work that we propose are create an ER dataset for fields such as address and target languages, also integrate the multiple models trained for each task into a pipeline, allowing translators to improve the classification model performance, and finally, and really important, annotate a significant amount of data as a slot filling task in order to train the whole process as an end-to-end pipeline. Finally, these are the team members of this project. First is Leah Tranchon, who has a bachelor in economics and computer science from Canada, and me, a bachelor in mechatronics and a research intern in computer science from Peru. Thank you for your attention.
Great. Thanks, William. Thanks, Leo. And now we're moving on with Mohammed's presentation on video generation and virtual characters.
Okay. Hello, everyone. This project is under supervision of 100% company, which is an Italian company in the field of animation generation. They are using traditional animation generation techniques, which are costly for them because they need actors, they need filming equipments, and experts. Therefore, all these challenges make them interested to somehow automate this process. In this slide, we will take a brief look at what they do currently. They have a kind of text. They must hire an actor and put a kind of motion capture equipment and attempt to read the text and then transfer these movements into the animation softwares. Let's take a look at this video.
There must be something. There's always something. I don't know about you, but I'm freezing. There must be something.
Okay. After that, they took this video and transfer it into the animation, the animation softwares. Somehow, the emotions or the way that that animation acts is not perfect. So they need an expert to tune different parameters. As you can see, in animation, we have some control rigs. That's why changing them, we can have different emotions and attempt the animation to talk. So let's see how this control rigs works. For example, we set this parameter. As you can see, when we change it, the mouse is going to change. Or for example, this could somehow control the smile. So until now, these two videos show how hard is this process to make an animation. So as we said, these are their challenges because they need studio, they need motion capture and filming equipments, they need actors. It takes several days for them to make these videos and then make the animation. And the animation generation pipeline is somehow costly for them. So what could be the solution? We want to use deep learning to help animation experts to generate realistic animations. So we want to make a kind of friendship between deep learning and animation generation. So to do this task, we went on our community and read very novel papers in this task. We found a very good paper which is very near to our task. It's published in 2018, and this is more information about the paper. This paper works in 2D facial landmarks, but in our project, the company wants us to produce 3D landmarks because each control rigs or landmarks has X, Y, and Z. So we have to change this paper in a kind of that fits our model. As I said, some control rigs are only translation based. They have X, Y, Z coordinates. Some of them has X, Y, Z plus roll, pitch, and yaw, and some others are only between an interval between 0 and 1. So we have to change the structure of this paper that fits all these three sorts of data. In this slide, we show the results of the paper that we have attempted to re-implement. This is the 2D version of the paper. And this video, which I want to show, is our implementation. So let's first take a look at the paper's implementation.
I laid down the paintbrush and mused. Do you remember, Elsie?
Okay, and this video is our implementation in 3D dimension.
I laid down the paintbrush and mused. Do you remember, Elsie?
As you can see, the result is promising and good. So
I laid down the paintbrush and mused.
Now I want to talk about the challenges that we have in this project. First of all, we had to extract data from FX file and Maya files, which are unknown sources for us as computer scientists. So we had to enter into a new world as a solution, the world of animation generation. It was the first challenge. The second challenge was that the paper we found was based on 2D facial landmarks. So we had to change it into 3D facial control links. So we had to change the model structure. The third challenge was the small data set. Unfortunately, we were given around 1,000 videos of 3 seconds. And this is very few to train a good model. So we used pre-trained weights from the paper and add another layer that transfer those 2D information into 3D information. The next challenge was that we got access to the full data a bit late at about week 5 out of 8. In order to extract the control rigs, we were just provided 1 frame of animation. So we had to extract the control rigs from that and do our experiments on that. And for the building the model, the only chance that we have was to use artificial data and make data by our own. And this was the solution to very, very late access to data. And the last challenge, which is still not solved, is a quality evaluation of the model. Unfortunately, in our community, there isn't any metric to evaluate how good is the generated models. And the only way to evaluate the model is to use an expert that see the videos and decides whether the video is good or not. We were a team of 2 people. Me, which my name is Mohammed Kamel. I'm a research assistant at SCIIP lab. Currently, I'm doing my master in computer science at Sapienza University of Rome. And my field of expertise is deep neural network and machine learning. And my colleague is Verdan. He got his PhD in electrical and electronics engineering. And Verdan is a very strong software developer with a background in machine learning. So thanks for your attention.
So, hello, my name is Marcelo Albuquerque, and together with Marco Micheli, my mentor and stakeholder on this project, I have been working on the Translation Quality Assurance by School Challenge. This project has been sponsored by Translated. Translated is an Italian company that offers human translation services in over 190 languages. It matches customers with thousands of translators worldwide. Each translation job goes through a sequence of a machine translation step using the modern NMT engine and a human translation step. The quality of a given translation job is assessed by human reviewers, which categorize and count each identified translation errors. Due to an inherent subjectivity of the translation error reviewing process, it's very common that different reviewers identify a different number of errors on each translation job. This makes comparisons of translation scores difficult and leads to noisy error score estimates. Not all reviewers are equal, and some show systematic biases, identifying more errors than others. To mitigate this problem, translation companies commonly employ simple average corrections and multiple review workflows, but these incur an additional costs and do not provide reliable uncertainty estimates of translation error scores. To cope with the different sources of noise in the translation score estimates, we identified latent factors that contribute to the number of reviewer-detected errors on each translation job, namely the latent factors: job difficulty, translator skill, and reviewer strictness/leniency, all of which contributes to the number of identified translation errors. Our solution consisted of a Bayesian beta binomial generalized linear regression model implemented using the PyMC3 library. The beta binomial is a standard choice of distribution to model over-dispersed counting processes. We use hierarchical structures for covariates representing job difficulty, translation skill, and reviewer strictness, making it easy to perform bias correction for reviewer systematic errors. Using a Bayesian methodology, our model assesses the full posterior distribution and thus the uncertainty associated with each error score estimate, which is a novel application of Bayesian uncertainty estimation in the translation industry. Posterior distributions of biases for the strictness of each reviewer and for the skill of each translator were evaluated on an experimental dataset provided by translator. The biases indicate that indeed some reviewers may increase while other reviewers may decrease the odds of translation errors being identified, which we interpret as an indicative of reviewer strictness or leniency. Identifying the systematic biases, our model enables the correction of undesirable systematic errors and the evaluation of more reliable translation error metrics. For each translation job, the model provides an assessment of the reviewer bias corrected estimates of error scores. In this plot, we can see in black observed error scores for a sample of translation jobs in our dataset. The colored dots and intervals show the posterior bias-corrected credible intervals of error scores. Strict reviewers, such as reviewer L, tend to have its error estimates lowered. Lenient reviewers, such as reviewer A, tend to have its error estimates increased. In this way, our model provides uncertainty assessment and bias correction of translation error scores using a Bayesian workflow, improving on the current adopted methodology that utilizes simple statistical averages. One opportunity for future work is to model different error categories such as style, accuracy, or linguistic errors. A Dirichlet multinomial model, which is a multi-category extension of the beta binomial model implemented in this work, would enable the evaluation of the tendency of reviewers to identify different categories of errors, for example. Our team consisted of me, Marcelo Albuquerque, an electronics engineer with a master's degree in computer science, and Marco Micheli, who served as mentor and stakeholder for the Spy School Challenge. Marco works as a research scientist at Translated and is currently a PhD student at Universidade degli Studi di Roma La Sapienza. Thank you for your attention.
Thank you, Marcelo. Excellent. Very technical and very interesting work here. I'm pretty proud to say, by the way, that within the translation industry, what we're doing here is perceived as rocket science. So we thought it's a really good idea to apply Bayesian learning to quality assurance. Many people are looking up to us.
Thank you.
Thanks. And now our next team will speak about the work we did with dream chips.
Yes, thank you very much. So hello everyone, my name is Attila and I'm representing a very special diverse team of 5 today, and our sponsor Dream Chip Technologies, whom we collaborated with to try and foresee what the future is. So what the future will look like, this is a broad, interesting question which would open everyone's eyes and minds to imaginative scenarios. And who asked us to do so was Dream Chip Technologies, which is a German company providing tailored product development from scratch to SLC level, adding up 30 years of development in camera and video application. They've partnered up with Allelica, Samsung, and ARM with 95 engineers out of 108 employees. Our problem or difficulty we're tackling is reference to several limitations taking place in mobile photography that let its users to own different extra gadgets or devices to satisfy their photography needs, as well as how the revolution in mobile cameras has been slightly monotonous with enhancements recently. our goal is spread on different aspects. We were having the chance to work on an AI challenge with Dream Chip Technologies and trying to foresee the user needs and their leisure, joy, and photography through their mobile devices, as well going over limitless ideation and how to enhance their photography experiences. Our strength, oppositely to the 95 engineers out of 108 employees, is diversity. 3 product designers with different extra backgrounds ranging from UX, archaeology, linguistics, teamed up with 2 really skilled engineers from the field of AI and computer vision development. So we combined our powers through our different methodology plans. We actually started with market research and UX investigation, had extensive brainstorming sessions which led to ideation development. And this development led us into 3 major approaches, which are main basic solution groups. The first one is reality creation. We were doing environmental and spatial analysis, which leads to 3D reconstruction and therefore can be used to different usabilities. The second is the camera portability, where we have camera lens transmission and camera movability. And last but not least, the medical and public safety approach, where we solve matters through mobile lenses and their softwares. Going back to the question we started with, we envision the future of image processing featured and algorithms in about 5 to 8 years from now, and build a futuristic, innovative photography approach. And if we do a reality check, the percentage of smartphones and the smartphone users today are around 50% of the world's population, and that's a major market through the mobile cameras and chip production industry. And this is the dream team, and to give a final answer to the question as a takeaway we all learned and are thankful for, the future is not foreseeable. But with the good thinking, the good research and approach, the choosing from the path in front of us and using it with sensitivity to the people and make the future by one of these opportunities will give us what we are looking for. Thank you very much for your attention.
Thank you so much, Attila.
Thanks.
Really exciting stuff.
Sorry?
It was really good. Thank you.
Okay.
Really exciting. And
Thank you.
I'd like to comment also that this, indeed, just like Attila pointed out, this challenge was a bit unusual for PySchool. You have seen all the rest of the, really of the 72 challenges that I just mentioned, the 71 others. They're really engineering challenges. And this time here, we tried something different because, well, we were in a trusted relation with DreamChip. They trusted us, we trusted them. And so the setup was a bit different. As you see, we had an extended team. It wasn't just engineers, it was also designers and people with background in UX, in what users like, in beauty, I would even say, certainly in stuff related to photography, the market related to photography, mobile, and so forth. And so we did this challenge with that good level of trust, and I think it worked out really well. I know that there are people from DreamChip on the call, so I won't make anyone blush, but we're really happy to collaborate, to receive that trust, and to be able to deliver on trust. So thank you very much. Okay.
It was a pleasure. Thank you.
Thank you. So after this great talk, we'll have a talk from Rob, from another dream team here, in the healthcare domain? Thanks.
Hello, everyone. Well, the title of this is Finding Key Opinion Leaders in the Medical Specialties. My team is Lavanja, Mohammed, myself, and Hossein. The sponsor is McCann Health. McCann Health supports a pharmaceutical company in finding key opinion leaders. Key opinion leaders are members of the academic community that have advanced knowledge in some specific medical issue. They are influencers in social media terms. And they are important to pharmaceutical companies because they sometimes hire them as consultants, and having the right people for the right work is essential for success. McCann Health has traditionally performed this research by browsing sources and collecting information in what is called a desk research. And the disadvantages of this is they can only analyze a small number of people. It is hard to understand how these QOLs are connected, and it is, of course, a time-consuming task. The solution that we propose is a semi-automated method to efficiently extract QOLs in medical areas. We are using API and web scraping tools, and also some manual collection. Our most important work is to feature engineer some, for instance, a domain-specific scientific impact factor. We're also building a network of QOLs for finding new QOLs, or also to figure out the number of connections a person has. To be able to run the QOLs, we are using a weighted sum from several aspects. The value that we bring is that we can cover a long tail of QOLs. But what that means is that we can analyze a large number of people, which can be difficult to keep track. We are automating some steps of the searching strategy, and we are improving because we are doing first a breadth first approach, and then they can follow with a deeper, more detailed searching. This makes the time and human resources use more efficient, and we can bring a unified view of the scientific, social, and also the political impact of a researcher. In this work, we analyze 3 therapeutic areas, but this method is adaptable to other areas as well. So this diagram shows the general overview of the solution. We'll start with a list of names, which we call seed names. They can be from the desk research, or we can also generate these seed names from the literature. And for these people, we analyze 3 different aspects. First, the political, which is related to the leading positions in relevant scientific societies. Also the social impact. This includes social networks, but also the number of mentions a person has been mentioned in some news or in some local or international news. For these sections, we use some name entity recognition algorithms to find out some names. For the scientific aspect, the ranking of the QOL is based on the publications. For this set of publications, we can extract features or statistics like the H index or the number of publications or citations. And we can also create a collaboration network of how these people are collaborating in different works, scientific work. This network can be useful also for ranking. You can see which person is very well connected, and you can also find new names which might not appear in the first round of this analysis. All of these aspects, we put them together in a weighted sum, and we rank these names. We are providing a file which is interactive for the user. So depending on the analysis, you can have more weights for the publications, or more weights to the social or the political. This is an example of fiction person for a fiction person. So you can have all of these scientific features, the specialization, publications. You can also have some features about social and political, and also the position of this person in the network. So how well connected this person is. This is a video that shows a graph. In this case, it's around 1,000 nodes. This is people collaborating in different papers. You can see some edges are wider. That means that these people are working in a lot of words. And also the size of the node represents the productivity of this researcher. Based on this graph, we can have in future work more insights. You can see more connection, and you can find the non-obvious patterns from the data. From a pool of around 1,500 researchers, we obtain these total numbers. So for instance, in each area, it started with 30 names. These names were provided by the desk research, so these were done manually. And from each of these 30 or 40 names, we were able to extract all of these names. Like in total, it's about 700 names. This is the team. So Lavanya is a PhD candidate in astrophysics. Mohammed, a data scientist at IBM. Myself, Hope Quiroz, a PhD in computer science, and also Hossein. So we have vast experience in data collection and data analysis. And well, we'd like to thank the PySchool and McCann Health for their support in this project.
Thank you. Thanks, Rob. Amazing.
Thank you.
Really good. So then, amazing results achieved only through the amazing work of amazing people. So I'd like to give a big thank you to all our fellows for the energy and enthusiasm that they put into this. It was really a great experience. So I'd like to thank Lavanya, Mohammed, Rob, Hossein, Ori, Attila, Marcelo, Francesco, Vardan, Hussein, Oliver, Leo, Mohammed, Ismail, Zeno, and William. And as you can see, quite some diversity too. As I said earlier, we're covering a number, I haven't counted them, but a number of time zones here. We have almost as many countries or nationalities represented as we have people. So thank you again, amazing work, teams. This was really good. And I'd also like to give a big thank you to our sponsors, the other part of the equation, if you will, that make this work. So thank you, a heartfelt thank you to Translated, to McCann Health, Italy, to Otomio, to 101%, and to DreamChip. It was really great to collaborate with you, and I hope we have the pleasure of doing this again. Now, I'd just like to say a couple of words for people on the call here who would like to participate or join us in one way or another. So if you feel that you would like to participate in School of AI, then please apply on our website. It's pycampus-school.com, and you click here on Apply Now in order to apply to the next session, which, as I said earlier, will take place end of this year. You can also go back to see us on one of the technical talks that we have recorded on our YouTube channel. So this is the latest that we had in May, a couple of weeks ago. This was with Łukasz Kaiser, who's one of the inventors of the transformer model. The transformer model in machine learning is, I think, the hottest model at all. It's being used to revolutionize the field of natural language processing, so text understanding, and now it's starting to make a big difference in computer vision as well, and I'm expecting that it might take over other fields of AI as well. So we were very lucky to have Łukasz, who is one of the mentors at PySchool, also give this technical talk. You can find it again on our YouTube channel. And join be one of the 20,000 people I see now who've enjoyed this video. A really great talk, actually. I'd also like to mention other news that might be, or information that might be interesting for people who are interested in AI. So Translated has opened a new research center called Imminent. So you can visit imminent.translated.com. Two interesting bits here. One is, I have it here. One is this research report. So this is the report that's been produced by Imminent. It's a really interesting piece of work. It's a book, as you can see. So you can get the PDF on the website. And if you'd like to obtain a hard copy, you can write to us and we'll send it to you. Imminent is about language and technology and the interface between the two, which clearly is what we as Translated, we're very keen on. And apart from this research report, I wanted to mention that Imminent is launching a big grant action. We have research grants. So in September, we will distribute 100,000 euros in grants over 5 grants, 20,000 euros each, on those topics that are listed on the slide here: language economics, linguistic data and data collection, data quality issues, biases in data and so forth, machine learning algorithms for translation, human-computer interaction, and neuroscience of language. So the application process is really simple. It's in multiple stages. At the first stage, you just basically need to tell us who you are, and then we'll contact the shortlisted candidates to know more about the project that they'd like to work on. Submission deadline is this summer. It's in July. So I know that I've already spoken in the last few weeks. I've already spoken to a number of you who would like to participate and apply with their challenge here. I just encourage you to go ahead with that. Think big. Think how you can make an impact on the big problems of language and technology. What we're working on at Translated is how to make everyone understand each other and be understood. And we think that helping other people outside Translated make progress in these directions is really important for the success of our vision overall. So for startuppers, you can apply at PyCampus with your idea, pitch us, and then we invest into the startups that we like best. If you're an AI researcher, then please apply to these Imminent grants I just mentioned. If you're learning AI and you'd like to get better at that, please apply at PySchool. Again, I'd like to thank everyone. I'd like to thank you as our precious audience for joining tonight. I hope you enjoyed this round of pitches, of challenge presentations. Thanks to you, the School of AI Fellows, you're now turning into alumni, and everyone else as well. Thank you and goodbye.
Thank you.
Thank you. See you soon. Bye.
Thank you, everyone.
Thanks a lot.
Bye, everybody.
Thank you all.
Bye.
Congrats,
Bye.
everybody.
Bye. Thank you very much.